um, 18 in the textbook, and it tells us that a Rotaride carnival, and people are rotated on a walled room, and the room it gives you the radius, which is 4.6, and it gives you the frequency, and it asks for the minimum coefficient of static friction so that people will not slip out. So what I did, I first drew a picture of it over here, and then I drew a free body diagram of one person, and I showed the normal force and the force of gravity, and the friction force, which is normally negative, but right now we're making it positive because that's how I labeled my axes. And so I wrote out the equation: net centripetal force equals mass times the centripetal acceleration. And so for my x, I wrote the force of friction is equal to the mass times the centripetal acceleration. And for my y's, I wrote that the normal force minus the force of gravity is equal to the mass times the centripetal acceleration. So after that, I wrote out my friction equation, which is friction force equals normal times mu, or the coefficient of friction. And then I also wrote out the equation to find the centripetal acceleration, because as I started solving for mu, I've set, so if friction force was equal to mass times centripetal acceleration, I said centripetal acceleration must be equal to the centripetal acceleration plus mg, which is the force of gravity, times the mu. And I so I solved for mu by dividing by mass times the centripetal acceleration plus mg, and then I solved for the centripetal acceleration, which I found by first finding uh, the tangential velocity, and then solving for the centripetal acceleration, which was 4.45.4, and then I plugged it back into my equation, and I solved for mu, which turned out to be 0.822. And the problem also asked, is there a really outward force pushing on the wall? If so, what, like against the wall? If so, what is a force? It is not true. It is the myth of the centrifugal forces, which are not true. Because what's really happening is that the force is pulling it in, and the wall is really banging into the person, pushing them towards the center of the circle. There's no force acting on them from outside. It's just from the center, the centripetal force. And so that would be the proper description.